Hello and welcome to my second maths video. Today we're going to be solving a question about systems of linear ODE. So we have this question right here. What is it telling us to do here? Find general solution of the linear system. Determine the type and stability of its critical points. Critical points right here. Okay, so we have this linear system ODE here. What is the first thing we do? This is actually related to matrix called eigenvalues and eigenvectors. So eigenvalues, how it's done. Okay, we put the numbers out here. y1, that's definitely 1, -2, -2, and 1. We put out the numbers and put it as an augmented matrix equals to 0. And then we minus lambda on the diagonal side. Top left to bottom right. 1 minus lambda, -2, -2, 1 minus lambda. And after that, what we do is we find the determinant of that matrix. Okay, so now we're trying to find the eigenvalues. 1 minus lambda multiplied by 1 minus lambda. So we multiply this one by this, minus -2 times -2. That's 4. So we put negative here, 4 equals 0. And now we just expand and factorize it. So what we got here is 1, negative lambda, negative lambda plus lambda squared minus 4 equals 0. And now that's going to be -2 lambda plus lambda squared minus 3 equals 0. And now if we factorize this, we can have lambda minus 3 and lambda plus 1. Okay, now that we found, we have to write lambda equals 3 and lambda equals -1. Okay, these are the eigenvalues. Now that we found the eigenvalues, we're going to find the eigenvectors. Okay? Now for the eigenvectors, each one we have to find it individually. So this one, we sub in lambda 3, and then we sum in lambda -1. Solve for lambda equals 3. One minus 3, -2, -2, 1 minus 3. That will be -2, -2, 0, 0, -2, and -2. Now what we're going to do is using row reduction. Okay, so row reduction is what we use so we can get the bottom row zeros. Okay, so how can we get 0 on the bottom side? We can minus R1 with R2. 1 minus R2. This also works. You can also make the top row zeros. Now, if we sub in, we can check row 1, -2, minus 2, and that will be 0. -2, -2, 0, 0, 0, 0. Okay, now what we do is sub in for negative 2x1 minus negative 2x2 equals 0. Now we're trying to find the eigenvectors, so that's what we do. This one is x1 and this one's x2. Now we try to make x1 the subject, so we move x2 to the other, negative 2x2 to the other side. x1 equals 2x2. Now we divide negative 2, and that'll be x1 equals negative x2. Make it into an augmented matrix, so that'll be 1 and negative 1. Okay? So now we found the eigenvector for lambda equals 3. Now we're going to do lambda equals negative 1. So we just sub in 1 minus 1, so that's plus 1, negative 2, 1 plus 1 equals 0. Now what we do here is add them to negative 2, 2, 0s. Now, next step, row reduction. Row reduction, I like to do the second row. So what do we do here so we can make the bottom row 0? We can plus it. 1 plus R2. We can put 2 plus minus 2, and that's 0. Negative 2, 0, 0, 0, and 0. Okay, now we sub in for x1 and x2. Okay, move to the other side. 2x1 equals 2x2 divided by 2 divided by 2 cross. No, sorry, this one doesn't cross. Yeah, cross that. Cross x1 equals x2, so that will be automatically 1 and 1. Now what we do here is sub it in to an ODE, make it the answer for the ODE. Okay, so we have here this vector, eigenvector, and then we write down C1 C1 1 negative 1 E lambda, and what was lambda here? 3 x plus C2 1 1 E to the power of negative 1 negative x. Okay, so now we found A. That was A right here, which was the general solution of the linear system. Now we have to find and determine the type and stability of its critical points. So it's going to be here. We have the determinant here, A equals 1, negative 2, and 1, right? Now what we do is for P, for point P, it's A11 plus A22. So diagonal like that. And that's how we find point P. The 1 plus 1 equals to 2. And that 2 is larger than 0. And now how to find Q? Q is actually the determinant of A. So that will be 1 times 1 minus negative 2 times negative 2. And that will be 1 times 1, negative 3. And now we sub it in to the equation of the critical points. So that will be 2 squared minus 4 times -3 minus 4 times -3. And that will be sorry, so just once. Sorry, my bad. So it's just p squared minus 4q, okay? And that will be just 16. Okay, now, both of them are larger than 0, so that will just make it a saddle point. And done. So what we did here was summary. We have this linear system ODE. Find the eigenvalues, determinant, factorize, and we got the eigenvalues right here. And then we find the eigenvectors for each one. Lambda equals 3, this is our eigenvectors. Lambda equals 1, this is our eigenvectors. And then we put it as in a linear ODE form. Second step, this is a critical point. To find P, we plus A11 and A22, so that's A11. That's A22. That was 2. And to find Q, we find the determinant of A, and then we solve in using this equation to find if it's either a saddle point or else. Find here was saddle point.